Okay, so today's notes are 3.8 human population dynamics. And so let's begin by talking about the ways that human populations can grow or decline. So this can happen either naturally through increased birth rates or immigration or infant mortality and death or emigration. And we talked about each of those four ways. And we even looked at the population growth equation to determine what the population growth actually was, and how that changes. And so it can also grow, populations can also grow or decline anthropogenically. So through societal development. So we've seen huge population booms when we talk about the introduction of modern medicine, by looking at nutrition and wellness, by looking at how in education impacts populations, excuse me, and also by sanitation, just by having cleaner living conditions. We've seen that cuts down on the rates of disease, which increases populations, keeps us healthier. So that's all very important. Industrialization caused exponential growth in the human population, and that population is still occurring. We're actually, at some point in this unit, we're going to watch a video about how populations have changed, how the world population has changed over time. So we'll be looking at that, and then that you'll see as soon as industrialization happens, and then modern medicine, and then technology, the population just exponentially grows. So it's actually kind of frightening how quickly it's growing at this point. Okay, so in this section, there's going to be a couple of different equations that you need to be able to use and apply, and these will be also on this test. Unit 3 is sort of heavy. Unit 3 and Unit 6, our energy unit, are both kind of heavy with equations that you need to be able to know, understand, and apply. So the rule of 70 is the first calculation. This is the time that it takes in years for a population to double. It's equal to... wait, let me repeat this. Oh, I see. This is just the equation written in sentence form. Sorry, that kind of confused me for a second. So it's the time that it takes in years for a population to double, and that is equal to 70 divided by the growth rate. Okay, so the equation is just right here. So here's the doubling time that it takes in years. We take 70 divided by R, which is the growth rate. And we can either do that, we can look at that in percent form, or we can adjust it. If it's in decimal form, then we can actually adjust it. And just instead of this being 70%, it would now be 0.7. Okay, so very simple. So there's two ways that we could look at this. If our population growth rate is 7%, we can take 70% divided by 7%, cancel out those percentages, and we end up with years. Okay. Or we can do 0.7 divided by 0.07. We get the exact same number. So it doesn't really matter. As long as you realize that you're working, you can't take this percentage and then divide it by a decimal. Okay. So it needs to be percentage divided by percentage, or decimal divided by decimal. Okay. So let's look at an example. If our global growth rate is 1.2% currently, how long will it take the population of the Earth to double in size? And so when we do the math here, it's 70 divided by 1.2 is going to equal approximately 58.3 years. So in just under 60 years, the population can actually double in size. Right now, it's over 8 billion people, so I can't imagine what the world would look like with 16 billion people. Hopefully, we'll not ever experience that, but we'll have to see what countries are doing to keep their populations in check. Okay, so factors that affect human population growth. The factors that increase the population growth are higher total fertility rate, which increases the actual overall birth rate, high infant mortality. I can't talk. High infant mortality rate can actually drive up your TFR because of the replacement idea that you're replacing the children that passed away. High immigration level. So if there's a lot of immigration occurring into a country, that country is going to experience a high or an increased population growth. And then increased access to both clean water and healthcare. Okay, so clean water and healthcare are two factors that cause the population to grow quite substantially. All right, so then some factors, looking on the other side, some factors that actually decrease population growth rate. So obviously a high death rate, a high infant mortality rate, increased development, both with education and affluence. We saw that in our 3.7 notes. And then increased education for women, delayed age of first child, and postponement of marriage age. In other words, getting married at an older age actually decreases the fertility rate. Okay, so this, and then in turn decreases the human population growth. So, how do we calculate birth rates and death rates? So, to calculate either, you take the birth or the death rate divided by the total population, and that would give you a percent. And then you can either keep that as a percent, your birth rate, which is R, or you can change that into your CBR, your crude birth rate, by dividing that by 1,000, and that would leave you with a number. So a number per 1,000 births. So if we look at our example here, if we had 23,452 births and we want to see what the birth rate is, we would divide that by the total population, 942,721 people, and we would end up with 0.025. That is going to be equal to, if we multiply that by 100, that would be equal to 2.5% birth rate. All right, so we could actually take 70 divided by 2.5, and that would tell us how many years it would take the population to double. So there's lots of things that we can do with this birth rate number, but that is the overall birth rate for this population. Okay, if we wanted to change this into a crude birth rate, we would take this decimal, we would divide it by, or I'm sorry, multiply it by 1,000. No, divide it by 1,000, and we would end up with 25 per 1,000 births. Okay, so our crude birth rate, or our CBR, is 25 per 1,000. That's what I would say for that answer. Okay. All right, so growth rate equals R. Again, that's the letter that we use to connotate growth rate. And it's the percent increase in a population. And usually when we're talking about growth rate, we're talking about per year. What's the annual growth rate? They don't always say annual though, so sometimes it gets to be a little confusing. So don't be confused by that. An example, a growth rate of 5% for a population of 100 means they grow to 105 the next year. Okay, and so that's just kind of what that means. All right, and so here's this equation. This does not include, we're not looking at immigration, we're not looking at immigration for this equation. All right, so for this, we would take the crude births minus the crude deaths divided by 10, and then that is going to be equal to our rate. Okay, the reason we do this by 10 is because we've already divided this by 1,000. So we're not dividing it by like 100 to come up with a percentage, because we've already done it by 1,000. And so now we're just dividing it by 10. All right, so for example, 40 minus 30 divided by 10 would equal a 1% growth rate. Okay. Or we could also look at population change. And if we were calculating population change, we would do the births plus immigration minus the deaths plus immigration. Figure out that answer that's in parentheses for that whole top there. Then divide that by the total population times 100, and that would give us our percent. Okay. All right, so calculation, let's practice some of these equations just so we get the hang of this. And we will be doing this in class together. So if you're confused with these equations, hopefully I will clarify that for us in class when we're working together. All right, so calculating both growth rate and then doubling time. So a country has a CDR of 9 and a CBR of 18. Calculate the annual growth rate and the doubling time. So there's two separate equations that we're going to be talking about here. So the first is the growth rate. We're going to take that 18 minus 9. So we're going to take the birth rate minus the death rate, get that answer, 9, divided by 10, is a 0.9% growth rate, okay? That Yes, that's right. Okay. And then to figure out the years that it's going to take to double, we would take 70 divided by zero point 0.9. And then that tells us that, and that's 70% divided by 0.9%. So those are both percentages. And then we would end up with 77.77 years to double. Okay. So that is the doubling time and the growth rate. Okay. So let's look at calculating future population from growth rate. So this equation is just a little bit different because you have to look at it's almost like in math. I think in algebra 2, it has you calculate the interest over so many years. And so it's like a logistic log problem. Okay. And so you would take the initial population times the growth rate for to the power of however many years it is that you're looking at. And this is where it's like doing the interest problem. Like it's the interest rate for how many years would be the power that you multiply that to. And if we calculate this out, that'll give us a final population. So it's important to note here that a growth rate of 3% for this equation is expressed as 1.03. It doesn't really matter, but if you try to take 0.03 to the 10th power, it won't calculate it correctly. So you have to have like this number greater than 1, okay? So 1 doesn't change the equation. We add that on there so that we can use that rate, or the years, to the power years, okay? So a growth rate, if we were doing this, of 0.25% is 1.0025. So we're basically just turning this into a decimal that's greater than 1. So our initial population is 468,843. And then we have a 3% growth rate over 10 years. We want to see what the new population will be in 10 years. So let's say that this is the year 2020. We want to see if we continue to have this constant growth rate. Excuse me. What would our population be like in the year 2030? Okay, and so we can do the math, and that means that the population grows to 630,085 people. All right, so just an example of the ways that you can use those different equations. Again, if you're totally lost, we're going to practice these in class, and I even have extra practice for those of us that want a little bit more with answer keys and things like that. So don't panic. I promise you it won't be as bad as it looks at this point for some of you. Okay, I know math is scary sometimes. All right, so standard of living indicators. So the standard of living is what is the quality of life like for people of a country. And it's based on two different things. We look at two different factors. We look at gross domestic product, or GDP. This is a key economic indicator of a standard of living. And then we also look at life expectancy, which is a health indicator of our standard of living. So we've got economics and health that we look at, because population tells us one thing and population growth tells us something else. And so it's also important to look at the key economic and then the key health indicators to give us some idea as to how the population is prospering in an area. All right. So the gross domestic product, just to give you a little bit more detail, is the total value of the goods and the services that are produced in that country. Per capita GDP is actually equal to the gross domestic product, which is usually a dollar amount, divided by the total population. Okay. And then life expectancy, I think most of us probably understand what that is, but it's the average age a person will live to in a given country. So what's that average age? And that tends to be broken down by males and females. Females tend to live longer than males. Not always, obviously, there's always exceptions, but females tend to live longer than males. Sorry, guys. But the average age that a person will live to in a given country. And so we can look at, and those values are actually published for different countries, and that can give us an idea of the overall health of that country. So increases with access to clean water, healthcare, stable food sources, healthy diets, exercise, those sorts of, all those different cultural aspects as well impact life expectancy. So high GDP and high life expectancy are both indicators of a developed country and lower population growth. So that's how these two factors kind of tie into what we're talking about with this unit. Okay, this brings us to the end of this population dynamics section 3.8. So with this, you're going to describe one human activity related to a rapidly growing human population that is having an impact on biodiversity. Propose a solution a government could take to actually slow down population growth. And that's it for today. If you have any questions, make sure you're reaching out to me in class, and I'll see you guys next time.